ninth graders. Today we are going to finish up talking about how to prove triangles to be congruent. Last class we learned, last two classes, we've been focusing on side, 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 and angle, side, angle. And today we're going to add our last two ways to prove that triangles are congruent. And they are angle, angle, side, and hypotenuse, leg, which we got to talk about in our Kahoot. Today for me, but yesterday or maybe 2 days now for you guys. So we're going to talk about those two reasons. We're also going to talk about something called corresponding parts of congruent triangles are congruent, CPCTC. It's a super, super helpful reason to use in a proof if your final stop is not that triangles are congruent. If you need to prove triangles are congruent in order to prove something else, CPCTC is what we're going to be using. All right, so I would like for you to start under the angle, angle, side congruence theorem by drawing two triangles that look to be about the same. I'm going to, like I did with my other ones, call this A, B, C, and A prime, B prime, C prime. So in order for it to be angle, angle, side, you need to have an angle next to an angle next to a side. So that means you need to have two angles and it's not the side between them. It's two angles and then one of the other sides outside of it. So if I were to then pick some angles that I wanted to be equal, I would maybe say, let's have angle A be equal to angle A prime. And then let's have angle C be equal to angle C prime. And then in order for it to be angle, angle, side, it has to be either AB and A prime, B prime, or BC and B prime, C prime. It cannot be AC. If it was AC, it would be angle, side, angle. So I'm going to just choose one of them and say, let's do BC and B prime, C prime. Once you have said all of those in your proof, you can then very specifically, right, not just implied, like, oh, well, it bisects, so obviously these guys are equal, right? Or, oh, it's an isosceles triangle, so obviously these sides are equal. You have to state it. Once you've said all three of these pieces very specifically in your proof, then you can say that the triangles are equal or congruent, which is the same thing. Coronavirus does not stop loud motorcycles on the road, apparently. So we have those two triangles are congruent, and the reason is because of angle, angle, side. Last reason to prove that triangles are congruent. So our last reason is HL, which stands for hypotenuse, leg. Now, I know that it seems like there's only two things you need to prove here, but in fact, there are still three things that you need to prove between these two triangles in order for them to be equal. As you remember in our Zoom Kahoot meeting, we talked about HL as it has to be a right triangle. And then one of the legs of the right triangle, so L is for legs, so the 90-degree angle is between. One of the legs has to be equal to one of the legs over here, and then the hypotenuse has to be equal to the hypotenuse, right? So it's actually a version of ASS, but it's the only version of ASS that can prove that two triangles are congruent. And so as a result, we call it HL. So I would like for you to start by drawing two right triangles that look to be about the same size. I'm going to draw in this little right angle. I'm going to pick a side length that is equal or a leg that is equal, and then mark that the hypotenuse is equal. I totally forgot to label my triangles, so let's call that A, B, C, and oops, A prime, B prime, C prime. So in order for hypotenuse leg to work, you still have to mention three things. You have to mention that triangle A, B, C and triangle A prime, B prime, C prime are right triangles. In order to prove that, you have to prove that there is a 90-degree angle. So you would say, hey, there's a 90-degree angle. As a result, this triangle is a right triangle because definition of right triangle. So you would need to state that. You would also need to state that the leg is equal to the leg. So BC is equal to B prime, C prime. And then you would also need to say that the hypotenuse is equal to the other hypotenuse. So in this case, AC and A prime, C prime. Once all three of those are said in the proof, then you can say that triangle ABC is congruent to triangle A prime, B prime, C prime, and that is because of HL. So here we can see that we've got some two triangles. We're just going to practice spotting what is congruent and what is not congruent. So you can see here on the left, we've got MNL and QNP. And we've got some pieces that are equal. We've got that this segment is equal to this segment is equal to this segment. And so we've got two sides, and then it does talk about an angle here, but it's not just any angle. It gives you this little box right here, which shows that it's a 90-degree angle. So you know, because of vertical angles, that this guy, angle MNL, so that guy right there, and angle QNP, so that angle right there must be equal because of vertical angles. And since one of them is 90 degrees, then the other must be 90 degrees. All of these reasoning things that I'm explaining to you right now need to be set out in a proof. Hey, this one's 90 degrees because it's given to us in the diagram. This angle and this angle are equal to each other because of vertical angles. As a result, that angle must also be 90 degrees because of substitution or transitive property of equality. Now that you have both of those are right angles, then you could say that the two triangles, so next statement, then you could say that those two triangles are right triangles. And then you could say, okay, so now they must be equal because it satisfies everything about HL. So yes, they can be proven to be congruent. And so we are going to write a congruency statement. Triangle MNL is congruent to triangle QNP because of HL. Next one, we have another vertical angle situation. So beginning of class. I know that those angles are equal, and then I'm given that this angle is equal, and this angle, D and B, are equal. And then we're given that ED and AB are equal. We can prove that these two triangles are congruent. It's something we haven't talked about before, but another reason that we can use is that angles, it's hard for me to write when it's up tall like that. Angles of a triangle add up to 180 degrees. So add this new reason to your reasons sheet. I hope you've been adding all of these reasons to your reason sheet. So as a result, since angles of a triangle add up to 180, you know that B is equal to D and ACB is equal to DCB. So if I were to, I'm going to go in here and number this. I'm going to call this 1, and 2. I'm going to show you the steps in your proof, how you would be able to prove that that third angle is also equal. If you could already like look at it and be like, oh, I already know it, obviously, or I obviously already know it, good. Then here's how you show it in a proof. So you would say that angle A plus angle B plus angle 1 equals 180. And then you would say the same thing about angle E plus angle D plus angle 2 equals 180. Here we already know that angles 1 and 2 are equal and that angles D and B are equal. And now we want to prove that angles A and E are equal. So in order to do that, we need to get A and E to be in the same equation together. So we want to set these guys equal. So this would be step 1. This would be step 2. I would say angle A plus angle B plus angle 1 equals angle E plus angle D plus angle 2 are equal to each other because of transitive property of equality. Now I'm just going to focus on the algebra here because that's where we're at in terms of the steps. So we want A and E to be equal to each other and realize that B and D are equal to each other. So if we subtracted them out, they would cancel out, but we have to show that algebraically, right? Even if we know that they're equal to each other, we have to show that it's B on one side and B on the other. In other words, we have to substitute, right? So I would keep angle B in this equation and replace angle D over here with angle B, right? So that's a substitution. I'm just taking one piece out, right? Because I'm still keeping angle E plus, I'm still keeping the equal sign, and I'm still keeping angle A plus, right? I'm just taking out angle D from right here and then replacing it with angle B. Now, same thing here with angles 1 and 2. I know that they're equal because of vertical angles. I would have assumed, supposedly already proven that in my proof before this point. So now I'm going to replace one with the other, only one of them, so that way I can subtract them out and get them to go away. So how about in this case, I replace angle 1, and I'm going to say plus angle 2 instead. Again, it does not matter as long as it ends up being the same thing on both sides. Because now if I subtract angle B from both sides, they both cancel out. If I subtract angle 2 from both sides, they both cancel out, and all I'm left with is angle A equals angle E. And then you could prove, since those guys are equal with three arc marks, now you have all the angles equal and then one of the sides. So it could either be angle, angle, side, or angle, side, angle. Okay, so just a really quick spotting of them and learning one more reason that we can use.